piecewise function. It's broken up into different sections. We've got this roller coaster type of graph here, and we also have part of this linear graph that shoots up this way. So the equation is made up of the entire thing. And if I base some limit questions on this picture, you could actually learn a lot about the differences, the subtle differences that you might see. First of all, the limit as x approaches 1. Let's begin with that. When x approaches 1, what do limits mean? Limits are y values near a certain x. If we're near 1, what's the y value? The y value is 2. It doesn't make a difference if I'm talking about being slightly to the left of 2, or slightly to the left of 1, or slightly to the right of 1. Both the left-hand limit and the right-hand limit are 2. If that's the case, if the left-hand and right-hand limit match up to the same number, then that must be the overall limit. We can take a look further down on the graph at x as x approaches 2. Limits are y values near a certain x. If we're near 2, what is the y value? We're not exactly on 2, we're near 2. How high is the graph? Well, I meant to line it up a little bit better, but the height of the graph is 1. Again, it doesn't make a difference if we're talking about being slightly to the left. Okay, if we're slightly to the left of 2, we're heading towards 1. If we're slightly to the right of 2, means we're living on this side of the graph, heading towards 2. The y value is still 1. Since the left-hand and right-hand limits completely agree, you could say the overall limit is that number, is 1. It would be likely that you'll be asked a question like this. What is f of 2? Well, this equation represents f. This means what is the y value at x equals 2? And you can see that at x equals 2, there's a blank spot. So the answer would be undefined, because there's no height of the graph at x equals 2. So this would be the answer there. All right, finally there, we're going to finish up talking about x equals 4. Okay. What is f of 4? F of 4 means if x exactly equals 4, what's the y value? Well, the y value would be this darkened part right here, which would be about 2.2, I guess. If we're talking about the limits, it's a little bit different. What's the limit as x approaches 4 coming from the left-hand side? If we're to the left of 4, it means we have to stand slightly to the left of 4. And that y value would count up over here at near 1. So the left-hand limit is 1. If we take a look at it from the other side, as x approaches 4 from the right-hand side, it means we have to be to the right of 4. If we're to the right of 4, slightly to the right of 4, we're way up here at 2.2. The left-hand limit's 1. The right-hand limit's 2.2. If that's the case, what's the conclusion? The conclusion is that the overall limit does not exist. The limit as x approaches 4 does not exist, because the left and right-hand limits are heading towards 2 different y values. Well, that's a quick summary. Let me see if I can get into some work with infinity, and that'll close things off with limits. It's a crash course on limits. Hopefully it's balancing out with the instruction you're getting from your classes. All right. One last segment on limits. Limits as x approaches infinity. Basically, there are 3 different possibilities. You could have more power in the denominator. When there's more power on the bottom and it's weaker on the top, the answer will always be 0. And you can tell which is more powerful by taking a look at the highest degree, which is called the highest power, which is called the degree of the expression. The highest power on the top is 1. The highest power on the bottom is 2. So the bottom will win out, be more powerful, and the graph will head towards y equals 0 as x gets bigger and bigger. If there's a tie with the exponent, right here, the top is just as powerful as the bottom. It has nothing to do with other numbers. You're comparing the degree of the polynomial. The highest degree on the top is 1. The highest degree on the bottom is 1. Since it's a tie, you rip off the leading coefficients, which are the numbers in front of those x's. So the answer there would be 2/3. As you get closer and closer to infinity, the graph will get closer and closer to 2/3. Finally, in this last example right here, there's more power on the top, and it's weaker on the bottom. Since it's weaker on the bottom, the top is going to be growing out of control. The bottom's going to be getting bigger faster than the bottom. So if you picture 1 billion divided by 1,000, that's still a pretty big number. Or 1,000,000,000,000 divided by just 1 billion. It's going to be a very large number. So in this case here, the answer will be infinity. Occasionally on the last example, it could also be negative infinity, and that would be kind of a weird situation, but it could happen. And that would be if the highest power here, or the lowest power here, had a negative and the other one was positive. In that case, as the graph got larger and larger, the graph would be heading, or as the x is getting larger and larger, the y value would be heading lower and lower. That's a quick wrap up on limits, and I hope it helps.